Welcome to Suresh Bhatt classes. We are solving quantitative aptitude topic on numbers. Please watch all my videos on this topic as well as all other topics of quantitative aptitude. These videos will be helpful for all competitive exams like railways, bank PO, SSC, CGL, etc. as well as in many job interviews. These videos will also be helpful for many entrance exams like SAT, ACT, GRE, GMAT, CAT, etc. We go to the questions. Our question is A, B and C are prime numbers and A plus B plus C equal to 74. Then what can be the maximum value of A? The given options are option A 53, option B 59, option C 61, option D 67. Before solving this question, I request you to please subscribe to this channel. It is given that A plus B plus C equal to 74, where A, B and C are all prime numbers. As 74 is even number, it means that one of the number must be 2 and the other two numbers are odd prime numbers. Then sum of these three can be 74. So we first subtract 2 from 74 and we get 72. Now 72 is sum of two other prime numbers, and now one by one we will subtract the lowest prime numbers from 72. 72 minus 3 is 69 and 69 is not a prime number. Next, 72 minus 5 is 67 and 67 is a prime number. Thus A equal to 67, B equal to 2 and C equal to 5. These are the three prime numbers and the sum of A plus B plus C is 74. And from the given options, our answer is option D. Hope you have understood the method of solving the question. We go to the next question. Our question is, if X is a prime number between 90 and 100 and Y is number of prime numbers. It's important. Y is number of prime numbers between 0 and 50. Then X minus 4Y is equal to option A 45, option B 41, option C 37, option D 33. Before solving this question, I request you to please subscribe to this channel. The prime number between 90 and 100 is only one number, which is 97. So X equal to 97, and there are 15 prime numbers in between 0 and 50. So Y equal to 15, as it's given that Y is number of prime numbers between 0 and 50. So Y equal to 15, as there are 15 prime numbers in between 0 and 50. Now we can solve the given question, that is X minus 4Y is equal to 97 minus 4Y is 4 times 15, that is 97 minus 60 equal to 37. And from the given options, our answer is option C, 37. Hope you have understood the solution. We go to the next question. Our question is, how many of the following are prime numbers? The given numbers are 1, 127, second 131, third 137, and fourth number given to us is 139. The given options are option A 1, option B 2, option C 3, and option D all 4. Here in this question it is asked how many of these are prime numbers. So if one out of this is prime number, then we have to have the answer as A, which is 1. If two of these are prime numbers, then our answer will be 2. If three of these are prime numbers, then our answer will be 3. And if all are prime numbers, then our answer will be all 4. Before solving this question, I request you to please subscribe to this channel. As we know from the basics how to test whether a number is a prime number or not. First we will find a number whose square is just greater than 127. We are testing the first number 127, and that number is 12 whose square is 144. 144 is just greater than 127, and the number 11 whose square is 121 is less than 127. So we will take the number 144, and square root of 144 is 12. So we will divide 127 by all prime numbers below 12, and those prime numbers are 2, 3, 5, 7 and 11. 127 being odd number, it is not divisible by 2. The sum of the digit is 10, so it is not divisible by 3. And the ones place is not 0 or 5, so it is not divisible by 5. Now we test it for 7. So 7 times 1 is 7. Balance is 5. 12 minus 7 is 5. And we carry 7, so it is 57. And 7 times 8 is 56, and remainder is 1. So it is not divisible by 7. Similarly, the sum of the digits at even places and the digit at odd places, the difference of these two must be 0 or 11. The sum of the digits at odd places is 1 plus 7 is 8, minus 2 is 6, which is not 0 or 11. Therefore 127 is not divisible by 11. Hence 127 is a prime number. Now we go to the next number, which is 131. Again 131 is less than 144, which is the square of 12, and it is more than 121, which is square of 11. So we will take all the prime numbers less than 12, and those numbers I have already listed above, which are 2, 3, 5, 7 and 11. Now the 131 is odd number, so it is not divisible by 2. The sum of the digit 1 plus 3 plus 1 is 5, which is not divisible by 3, so it is not divisible by 3. The ones place is not 0 or 5, so it is not divisible by 5. Now whether it is divisible by 7, we will check it. 7 times 1 is 7, and 13 minus 7 is 6. We carry 1, which is 61, and 7 times 8 is 56. 61 minus 56 is 5. Hence it is not divisible by 7, because the remainder left over is 5. Now this is also not divisible by 11, as the nearest number divisible by 11 is 132, and this is 131. So it is not divisible by 11. As such, 131 is another prime number out of the given list. Now we go to the third number, which is 137. This number is also not divisible by 2, 3 and 5. We check it for 7. 7 times 1 is 7, and balance on subtracting 7 from 13 we get 6, and we carry 7, so it is 67, and 67 is not divisible by 7, as 7 times 9 is 63 and 7 times 10 is 70. So 67 is not divisible by 7, as it leaves remainder 4. Therefore 137 is not divisible by 7. Now this is not also divisible by 11, as the sum of the digit at odd places is 1 plus 7 is 8, and 8 minus 3 is 5, which is not 0 or 11. Therefore 137 is not divisible by 11. Hence 137 is also a prime number. Now next number is 139. This number is also not divisible by 2, 3 and 5, as the sum of the digit is 13, 1 plus 3 is 4, and 9, 13 is not divisible by 3. Therefore this number is not divisible by 3. As this is odd number, so it is not divisible by 2, and the ones place is not 0 or 5, so it is not divisible by 5. Now we check it for 7 and 11. 7 times 1 is 7, and 13 minus 7 is 6, and 69 is not divisible by 7, as the next number 70 is divisible by 7. So when we divide 139 by 7, we get the remainder 6. Now we check it for 11. 9 plus 1 is 10, and 10 minus 3 is 7, which is not 0 or 11. So 139 is not divisible by 11 as well. Hence all are prime numbers. Hence 127, 131, 137 and 139 all are prime numbers. Therefore our answer is all 4, option D. Hope you have understood the solution. We go to the next question. Our question is, the sum of all prime numbers between 40 and 50 is divided by 25, then remainder is option A 5, option B 6, option C 7, option D 8. Before solving this question, I request you to please subscribe to this channel. We have to find all prime numbers in between 40 and 50, and those numbers are 41, 43 and 47, and the sum of these numbers is 131. 1 plus 3 is 4, plus 7 is 11, and 4 times 3 is 12, plus 1 is 13. So the sum of these three numbers 41, 43 and 47 is 131. Now we have to divide this by 25, and 25 times 5 is 125, and on subtracting 125 from 131 we get 6. So our answer is option B 6. This way we can solve such type of easy questions. We go to the next question. Our question is, when largest 2-digit prime number is divided by 13 and 17, the remainders are A and B respectively. Find 3A minus B. The given options are option A 7, option B 9, option C 6, option D 5. Before solving this question, I request you to please subscribe to this channel. The largest 2-digit prime number is 97, and when it divided by 13, so 13 times 7 is 91, and 97 minus 91, the remainder is 6, and 97 when divided by 17, 17 times 5 is 85, so 97 minus 85 equal to 12. Therefore A equal to 6 and B equal to 12. Now 3A minus B. 3A is 3 times 6 is 18 minus B is 12 equal to 6. So our answer is option C, 6. I hope you have understood the solution of the given question. We go to the next question. Our question is x, y and z are prime numbers where x is less than y is less than z is less than 17. In how many ways the sum x plus y plus z is a prime number? Option A 4, option B 2, option C 5, option D 1. Before solving this question, I request you to please subscribe to this channel. First we list all those numbers which are prime and less than 17, and those numbers are 2, 3, 5, 7, 11 and 13. Now we list all those prime numbers whose sum will be from any three of these numbers 2, 3, 5, 7, 11 and 13. So those numbers might be 17, 19, 23, 29 and 31. Now these numbers 17, 19, 23, 29, 31 all are odd numbers, and sum of three odd numbers can only be odd number. So we cannot use 2 in the value of x, y or z. So our first set will be 3 plus 5 plus, if we take 7, then 3 plus 5 will be 8 plus 7 will be 15, which is not prime. Then we take 3 plus 5 plus 11. 8 plus 11 is 19. So this is prime. Our first set will be 3 plus 5 plus 11 equal to 19. Now next will be 3 plus 5 plus 13. But we find that 3 plus 5 is 8 plus 13 is 21. And 21 is not prime. Then 3 plus 7 plus 11. 3 plus 7 is 10 plus 11 is 21. That is also not prime. Now 3 plus 7 plus 13. 3 plus 7 is 10 plus 13 is 23. And 23 is a prime number. So our next set will be 3 plus 7 plus 13 equal to 23. Now we start with 5. 5 plus 7 is 12 plus 11 is 23 and 23 is prime. So our next set will be 5 plus 7 plus 11 equal to 23. Then our next set will be 5 plus 11 plus 13. This is equal to 29 and this is also prime. 5 plus 11 is 16 plus 13 is 29. Now we start with 7. 7 plus 11 plus 13. 7 plus 11 is 18 plus 13 is 31 and 31 is prime. So next set will be 7 plus 11 plus 13 equal to 31. This way we have total 5 such sum of x plus y plus z or x plus y plus z whose sum is equal to a prime number, and these sets are 3 plus 5 plus 11 is equal to 19, 3 plus 7 plus 13 is 23, 5 plus 7 plus 11 equal to 23, 5 plus 11 plus 13 equal to 29, and 7 plus 11 plus 13 equal to 31. And from the given options, our answer is option C, 5. We go to the next question. Our question is, which of the following prime numbers is the sum of two prime numbers? The given options are option A 41, option B 71, option C 79, option D 61. Here out of these numbers 41, 71, 79 and 61, we have to find which is the sum of two other prime numbers. Before solving this question, I request you to please subscribe to this channel. As the given numbers are 41, 71, 79 and 61, these all are odd numbers and the sum of two odd numbers cannot be odd number. Therefore, one of the two numbers whose sum is all these numbers, one of them must be even number, and the only even prime number is 2. So one number out of the two numbers is 2. Now we find the other number. So we subtract 2 from all these numbers. 41 minus 2 is 39. 39 is not prime. Now 71 minus 2 is 69. 69 is also not prime as it is divisible by 3. 79 minus 2 is 77. This is divisible by 11, so it is also not prime. Now last number 61 is our answer and we just verify it. 61 minus 2 is 59 and 59 is a prime number. So the two prime numbers are 59 plus 2 is equal to 61. So our answer is option D, 61, which is the sum of two prime numbers, and those prime numbers are 59 and 2. Hope you have understood the solution. This was very easy question. We go to the next question. Our question is, A and B are two distinct digits such that AB and BA form a pair of two-digit prime numbers. Find the sum of all such numbers. The given options are option A 132, option B 242, option C 418, option D 374. Before solving this question, I request you to please subscribe to this channel. A and B are two distinct digits such that AB and BA form a pair of two-digit prime number. So AB is one prime number and BA is, after reversing the digits, is another prime number, and we have to find all such pairs of two-digit prime numbers, and then we have to find the sum of it. So the prime numbers of two digits start from 11 and the last two-digit prime number is 97. But 11 cannot be considered into it as the digits are not distinct. In 11 both the 1 are same. So 11 cannot be considered. So we start from 13. Now 13, and after reversing the digits is 31. 31 is also a prime number. So 13 plus 31 is one pair. Now next number is 17. After 13 the next prime number is 17, and 17 on reversing the digits becomes 71. That is also a prime number. So we make 17 plus 71. The next number is 19, and 19 on reversing the digits becomes 91, and 91 is not a prime as it is divisible by 13. Then next digit is 23, and 23 and 32. 32 is not a prime, so that pair is not of our use. After 23, the next prime number is 29, and 29 on reversing the digits becomes 92, and which is even number, so divisible by 2. So that pair is also not of our use. Then 31 we have already used. After 29, the next two digit number is 31, which we have already used. Then after 31, the prime number is 37. 37 and 73. On reversing, we get the number 73. 37 is prime as well as 73 is prime. So next pair is 37 plus 73. After 37, the next prime number is 41, and 41 on reversing becomes 14, and 14 is not a prime number. Then the next prime number is 43, and on reversing the digits we get 34, and 34 is not a prime. So 43 and 34 are not of our use. The next number is 47 and 74. 74 is not a prime as it is even number. Then the next prime number is 53. 53 and 35. 35 is not prime as it is divisible by 7 and 5. Then next number is 59. 95 is on reversing the digit we get 95. 95 is not prime as it is divisible by 5. Then 61. On reversing the digit we get 16, and 16 is not prime. So all the numbers in the row of 61 on reversing will give the even number 6. So we leave that row of 61 to 70. The next number is 71, which we have already used in 17 plus 71. Then the number is 73, which we have already used in 37 and 73. Then next comes 79. 79 on reversing we get 97, and both are prime numbers. So next pair is 79 plus 97. Now all the numbers in the row of 81 to 90, as 81, 8 is even number. On reversing the digits we will get all even numbers, so that row of 81 to 90 is not of our use. Then in the numbers from 91 to 97, the only prime number is 97. So here completes our all the two digit numbers. If we add all these, 13 plus 31 is 44, 17 plus 71 is 88, 37 and 73 is 110, and 79 plus 97 is 176, and sum of 44 plus 88 plus 110 plus 176 is 418. And from the given options, our answer is option C, 418. This way we can find the sum of all two-digit prime numbers which are of the form AB and BA, and both of them are prime numbers. Hope you have understood the solution. We go to the next question. Our question is, if A and B are co-prime numbers where A plus B equal to 15 and A is less than B, find how many such pairs of A and B are possible. The given options are option A 3, option B 4, option C 6, option D 7. Before solving this question, I request you to please subscribe to this channel. Now we start making the pairs whose sum is 15. 1 and 14, both are co-primes. Next is 2 and 13, both are primes as well as co-prime. 3 and 12 not possible, as 3 is the factor of 12. Next possible pair is 4 and 11. Next is 5 and 10. And 5 and 10 are not co-primes, as 5 times 2 is 10. 6 and 9 both have common factor 3, so 6 and 9 is also not possible. Then next pair is 7 and 8. Both are co-primes. Now again, if we go, then it will start repeating 8 and 7, but A is less than B, so here 7 is less than 8. This way we have got the 4 such pairs: 1 and 14, 2 and 13, 4 and 11, and 7 and 8. So this way our answer is option B. 4 such pairs are possible. Hope you have understood the solution as well as the question. We go to the next question. Our question is, which of the following are prime numbers? The given numbers are, the first number is 241, second number is 257, third number is 331, fourth number is 377, and fifth number is 397. The given options are: option A, first, second, fourth and fifth are prime. Option B, second, third, fourth and fifth are prime. Option C, first, second, third and fifth are prime. Option D, first, second, third and fourth are prime. So we will verify all the numbers and will reach to the answer. Before solving this question, I request you to please subscribe to this channel. The first number is 241. We will find some square number which is just more than 241, and that number is 17 square. So we have to verify or check the divisibility of all those prime numbers which are less than 17. So 241 being odd number, it is not divisible by 2. The sum of digit is not divisible by 3, so it is not divisible by 3. As the ones place is not 0 or 5, so it is not divisible by 5. Now we verify it for 7. 7 times 3 is 21, balance is 3, and we carry 1, so it is 31, and 31 is not divisible by 7, so it is not divisible by 7. Now 11, as the sum of the digits at even places and odd places, the difference is not 0 or 11, so it is not divisible by 11. Next number is 13. So we divide 241 by 13. 13 times 1 is 13, balance is 11, and 111 is not divisible by 13, so 241 is also not divisible by 13. So 241 is a prime number. So I write it as prime. The next number is 257. Again, this is less than 17 square. So the same, the numbers 2, 3, 5, 7, 11 and 13, we have to check the divisibility of these numbers. This is not divisible by 2, 3 and 5. Now we check it for 7. 7 times 3 is 21. Balance is 4. And we carry 7, so 47. 47 is not divisible by 7. Therefore 247 is not divisible by 7. This is also not divisible by 11. Now we verify it for 13. 13 times 1 is 13, balance is 12. We carry 7, 127. On dividing 127 by 13, we get balance 10. So it is not divisible by 13. So it is a prime number. Now next number is 331, is less than 19 squares. So we'll divide 331 by all prime numbers less than 19. It is not divisible by 2. It's not divisible by 3 as the sum of the digit is not divisible by 3. It is not divisible by 5. It is not divisible by 7. We verified for 7. 7 times 4 is 28. Balance is 5. We carry 1. And 51 is not divisible by 7. So 331 is not divisible by 7. Now we verified for 11. 11 times 3 is 33. We carry 1. And 1 is not divisible by 11. So 331 is not divisible by 11. Now we verified for 13. 13 times 2 is 26. Balance is 7. We carry 1. 71. 71 is not divisible by 13 as 13 times 5 is 65 and 71 minus 65 is 6. So this is not divisible by 13. Now we have to verify it for 17. 17 times 1 is 17. Balance is 16. We carry 1. 161. 161 is not divisible by 17. 17 times 9 is 153. 153 when subtracted from 161 we get 8 and 8 is not divisible by 17. So this is prime. Now next number is 377. 377 is less than 20 square. So we have to check the divisibility of this number by all prime numbers which are less than 20. This number is not divisible by 2. It's not divisible by 3 as the sum of the digit is not divisible by 3. The sum of digit is 17 and 17 is not divisible by 3. It's not divisible by 5. Now we verified for 7. 7 times 5 is 35. Balance is 2. We carry 7 and 27 is not divisible by 7. Now we verified for 11. 11 as the sum of the digit as odd places is 3 plus 7 is 10 and 10 minus 7 is 3 which is not 0 or 11. So 377 is not divisible by 11. Now we verified for 13. 13 times 2 is 26. Balance is 11. We carry 7 and 13 times 9 is 117. So it is divisible by 13. So it is not prime. So the fourth number 377 is not prime. Now we verify the next number 397. This is also less than 20 square. So we verify the divisibility by all prime numbers which are less than 20. This is not divisible by 2. The sum of the digits is 19 which is not divisible by 3. So it is not divisible by 3. It is not divisible by 5 as the ones place is not 0 or 5. We verified for 7. 7 times 5 is 35. Balance is 4. We carry 7. 47. 47 is not divisible by 7 as 7 times 6 is 42 and balance is 5 which is not divisible by 7. So 397 is not divisible by 7. The sum of the digits at even and odd places 3 plus 7 is 10 and 10 minus 9 is 1 which is not 0 or 11. So it is not divisible by 11. Now we verify it for 13. 13 times 3 is 39. Balance is 0. We carry 7 and 7 is not divisible by 13. So it is not divisible by 13. Now we verified for 17. 17 times 2 is 34. 34 when subtracted from 39 gives us 5 and we carry 7. So it is 57 and 17 times 3 is 51. Balance is 6. So this is not divisible by 17. Now only number left is 19. 19 times 2 is 38. Balance is 1. We carry 7. So 17 is not divisible by 19. So this is prime number. So prime numbers are, first is prime number, second is prime number, third is prime number, and fifth is prime number. Fourth is not a prime number. Now we verified from the options. So option C, first, second, third and fifth. So option C. So our answer is option C. I hope you have understood the method of solving such type of questions and verifying whether the number is a prime number or not. Here completes this video. Please watch all my videos on quantitative aptitude, which are extremely useful for all competitive exams. Please do lot of practice from different books to become expert in solving such type of questions. Please like, share and subscribe to this channel, and don't forget to press the bell icon to get the latest notifications. Thanks for watching.